All right, ladies and gentlemen, last lesson of this pre-chapter, which before we get into, let's go back to the last one. So what were those three elementary functions? Well, our three elementary functions is algebraic, we have trigonometric, and exponential, and logarithmic. Which all three things we did last year in advanced math, and so we don't necessarily cover all of those here. We kind of build off of those a little bit and use them in calculus. But those are our three elementary functions of math. Now, what we're going to be getting into today is modeling real life data. So how can we use our graphing calculators to do that? Well, we can take data like this and come up with a linear regression line. So that line saying, hey, this is what these are all modeling towards. All of our heights and arm spans in this case are going to correspond like that. So we have a class of 20 people collecting the following data from which represents their height X and their arm spans Y rounded to the nearest inch. Find the linear model to represent the data. So what you're going to do is this. You're going to take your graphing calculator. I'm going to pull this out of the way for right now. But your graphing calculator, you're going to go to this button right here, Stat. Hit Stat, and the first thing we're going to do is we're going to come down here to number 4. We want to clear this list and hit Enter. Now, it's going to say, well, which list? Well, we're going to go then. Second, number 1, right above here is an L1. We want L1, list 1, is what we're going to be working with. We're going to put our X's into there. And then we're going to use a comma here, which is right above the 7, to separate our list. And then we're going to hit second 2 to get L2 there. So we're going to hit enter now, and that cleared list 1 and 2. Now, I've already gone through and put these in. But to put these in, you're going to then go hit that stat button again. And after I turn it on. So hit the stat. And the first thing we're going to do here is hit edit. So hit enter. And so what we're going to do is all of these, the heights, you're going to put into L1. The arm spans, you're going to put into L2. Now, I've already done that just to save time. So if you're watching this video, which clearly I'm making the video, so you should be watching the video. So watching this video, you're going to pause it right now, and you're going to put all of those in. So all of your heights in. So when you do it, you're going to hit, say, 60 and then enter. So then that'll move you to the next line. Don't forget to hit enter. So put in the number, hit enter, and it'll kick you to the next number. You're going to put all those in. Now, if you have, say, you get to the end and your lists don't match, which there should be 28 of them. And so at the end here, you should have even list. If one of those is missing, what you're going to do is this. So you're going to hit second insert, so second delete, and that will allow you to put in a number here. So then you can find out where you're wrong, put that in, so you don't have to enter all these in again until you get them even. Okay? But for right now, I'm going to delete those out of the way. So should have paused the video, put all these numbers in. Now you're ready to go. So what we're going to do is we're going to hit second quit to get out of here. And now we're going to go to stat. And we're going to arrow over to calc. Now we want a linear regression line. So we're going to do this lin reg, which is number 4. Now you can either hit number 4 or you can go down and find it. Now we want our X list to be L1, our Y list then to be L2. And then we want to calculate, so we're going to go down here to calculate and hit enter. Now, notice for a moment there, if it didn't pull up that last screen. So when you hit stat over to calc and lin rig, if it didn't pull up this screen, but instead pulled up this here for a moment, where it's linreg A plus B in parentheses, that's where you'll have to go second 1 to get L1, comma, second 2 to get L2, and then hit your enter to get your linreg. But they should be updated to where it should do this, but just in case your calculator isn't, or you're using your own that isn't, it should do that. Now, doing this, it's going to give you some stuff here. So it's giving you the equation y equals ax plus b. So for a, then it wants you to give this. Now, if you go out 4 places, that should be far enough for either your a or your b. So using this calculator, for our linear regression line, we should have y equals 1.006. I'm going to go 3 places. And x, I'm going to move this out of the way so then I can do this. So then minus 0.225. Now, if yours is a little different, it's okay. It should be somewhere around the same thing, though. It should be fairly close to these numbers is what you should get. Now, what this means is this. If I go into my y equals, I'm going to put this in here. So the y1 would be 1.006x minus 0.225. Now, when I go to graph this, I'm also going to turn on plot 1, which if I hit second y1, which is stat plot, we're going to go into here. And we want our list 1, list 2, we're using dots, and we're going to be a scatter plot graph here. But when I go to graph it, now you're going to see a line cutting through, but you don't see any points. Well, that's because look at what our numbers here. They're all 60 to, looks like 75 is the biggest one there. Down here we are 60, looks like to about that 74. So what I'm going to do is I'm going to go here, go window. My X's I'm going to change from, I'm going to go 55 to 80. And I'm going to do the same thing here, 55 to 80. So when I hit graph, now you see all these, and you see our line cutting through. So that's that best fit line is what we just found. Going through all our data, just that generalize that, hey, this is how it is. So for this much of a height, you should have this much of an arm span. Okay. So another one here. This time, we're taking a basketball, we're dropping it from a height of 5.25 feet, and we're going to take 25 different data points that are about 0.02 seconds apart. And then we're going to find a quadratic model for this graph. So again, you're going to want to go to, pull out my right calculator here. So, which you can go through your stat list and delete them all out. Or again, we can hit stat and go down clear list, and you'll hit second L1, comma, second L2, and then enter to clear it out. Okay. Now, you're going to go through all of your times, which you'll then hit second, or not second, just stat, edit. And so all of your times will go in your L1, which if I get the right one here. I also put these in ahead of time just to save time. So stat, edit. So all of the L1s are your times, your heights, then are going to be your L2s. So again, this is your time where you want to pause this video, put all these points in, and then resume the video. So again, if you're resuming now, if you have your lines that aren't, your list aren't even, find where you're missing, and again, hit second, insert, and that'll put one in there to match where you missed one. Or find out if you put one in wrong. But that's where you'll be able to go through and do that so that you don't have to keep entering all those points again, because otherwise if you go up here and say I put this one in, well now that one's changed, well now I gotta choose the next one and the next one and the next one. It doesn't just shift them all down, okay? Now, I want you to hear where you have everything all put in, hit second, quit, so second mode to get out of this. And then we're gonna hit stat, arrow to the right to calc. This time we're gonna do a quadratic model. So we want quad reg, so number 5. Now again, if yours doesn't come up like this, you'll be able to go second L1, comma, second L2, which is 1 and 2, second number 1, second number 2, with a comma in between to get your list 1 and 2. Now, we're going to do a quad rank, so quadratic regression model, and hit enter. So this pops up. Now we have our equation. So the equation we get here is y equals negative 15.449x squared minus 1.302x plus 5.234. Now, if you get something that's a little different, that's okay. But it should be fairly close to this right here. So again, if we go ahead and hit y equals now, and we put that equation in, so in your y1, we're going to do negative 15.449x squared minus 1.302x plus 5.234. And again, we're going to go up here to plot 1. We're going to turn that on, hit second y equals, and go in there. So again, it should be on. We want our list 1 and list 2 as our x and y. One of those marks, we're doing a scatter plot. And again, if we hit graph, it's going to be hard to see anything there. So what we want to narrow it down to is we know we're dropping it from 5.5 feet. So our y-wise, we're going to go from 5.5 as our max down to our lowest looks like 1.6. So we're going to change our window for our y's. Our min's going to be 0. Our max is going to be 5. As far as x's go, well, x's start at 0, and our last time is 0.43. So I'm going to go 0.5 for my max there. So when I hit graph now you can see that curve, and you notice our lines cutting right through all of those dots, which also is the same graph as right there, so it should match that. But again, we made that quadratic regression model, so we're seeing exactly where those points are going. All right. Now, last thing. We can create our own graphs, our own equations of these graphs as well, even if they are trig functions. So the number of hours of daylight on Earth depends on the latitude and time of the year. The following graph represents the number of minutes of daylight of location 20 degrees north latitude. Now, I'm not sure where we're at, but apparently we're at 20 degrees north latitude, which I believe is north of here. But I'm not 100% sure, so don't quote me on that. But what we're doing here is we're going to set up a trig equation. Now, it's kind of hard to see on this graph here, but this middle line is at 728. That's going to be our vertical shift. Now, the two different equations that we would use are y equals a cosine of 2 pi t over x plus, I'm going to do d here, or y equals a sine of 2 pi t over x plus d. Now, cosine starts away from that center line. Sine starts on the center line. So we're going to use cosine to begin with here. So y equals, A is going to be our amplitude. Which is how far it's going to go up or down from that center line. D is going to be your vertical shift. So how much have we gone up? Because normally we're going through our 0 line as our center. Here we're shifted up. Now, if you look here, you can kind of see 728. Of course, you really can't see on the screen here, but if you look at your notes, this is 728 is the middle. Now, up it says 73, down it says negative 73. So that's a change of 73 here. So that's your amplitude. A is going to be 73. So we're going to do 73 cosine, since we start away, of 2 pi t over, now, x is going to be how much is this spread over our graph? How does that change? Well, if we're doing 365 days, that's how it's changing by. So we're going to divide this by that 365. So normally one full revolution is 0 to 2 pi. Well, we're breaking up that revolution into 365 days because we want to know that, hey, t is our day that we are throughout the year, from day 0 to day December 22nd, it looks like. So day 0 is technically December 23rd of the previous year. But this bottom is going to be how far is it spread apart. So how long is one period? How long does that take? And then plus, well, we're shifted up. We're not over that 0 line. That center line here is at 728. Now, the only thing is, when we're looking at this, so now cosine, I'm going to write this down and we'll come back up. So cosine does one of these. It starts up, curves down, curves back up. Sine then starts up, curves down, come back up. So looking at our graph, we're starting down, curving up, going down. So what we have to do is we have to flip it over, and since it's a vertical flip, we're going to put a negative in front of the 73. If it was a horizontal shift, we would put a negative. So if we would have flipped it, say, this way, which it shouldn't because we're going to repeat, that would happen inside here. We would have a minus in front of this fraction. So this is our equation representing this graph. And that's it for this lesson. So chapter P is over. Next thing we're going to get into is some actual calculus. Get excited. It's going to be awesome. Don't worry. It'll be fine. But remember, you can always pause, and hopefully you did, especially during this video, to put those data points in. If you need more time before I move on, you can always rewind and hear me again go through something. Any questions, comments, concerns, send me a message on Google Classroom, pan me, email me. Any of those work. Otherwise, until next time, we'll talk to you later.